Remember the factor we've done so far. We did a greatest common factor. That's the first thing you always look for whenever you're factoring. The second thing was a standard form. This question is also a standard form, but the first one we did had the coefficient of 1 on the squared term, and those were much easier. So we did greatest common factor, standard form, and then difference of squares. That's when I have two terms, they're both squares, and I have subtraction. So first thing we look for is a greatest common factor. Then we have standard form. It has three terms, a square, a middle, and a number at the end. If the number in front is a 1, that's the easier kind where I can just say factors of the last number that add or subtract to make the middle. Difference of squares had two terms, subtraction, both squares. Now, as I said, this is also a standard form, but the difference is that 3 in front. When there's a number in front of your standard form, that completely changes how you factor. And the reason for that is that number helps create the middle term. Take a look at an example here. When I FOIL 3x plus 4 times 2x plus 5, watch what happens. 3x times 2x is 6x squared. 3x times positive 5 is positive 15x. 4 times 2x is positive 8x. And 4 times 5 is positive 20. And as usual, we simplify the middle. 8 plus 15 is 23. We get 23x plus 20. Now what I want you to observe is where that 23 came from. It came from the 15 and the 8. Remember how I've told you that in FOIL, first, outer, inner, last, the outer and the inner make the middle term. That's this one and this one. See, the 15 and the 8 that made the 23 came from a number in front, 3 times 5, that made the 15, and a number in front, 2 times 4. The 2 helped create the middle, that 8 right here, and the 8 and 15 made 23. My point is here, look at the 6. The numbers that created the 6, that was the 2 and the 3, those numbers help create the middle. They help create the 15 and the 8, which makes the 23. Because 3 times 5 is 15, and 2 times 4 is 8, and that 3 times that 2 makes the 6. So the number in front, the factors of the number in front, help create the middle term, which means, in this question, 6x squared plus 23x plus 20, you can no longer say factors of 20 that add to 23. It's really factors of 6 and 20 and a combination that adds a 23. So what do? The easiest way to factor a standard form with a number in front is to turn it into a grouping problem. We had a few examples in one assignment where we factored a grouping problem. A grouping has 4 terms. So you're going to split this middle term up into 2 terms, creating 4 terms. The way you do that is you take your first number, the 3, the last number, the 28, you take the 3 and the 28, and you multiply them. 3 times 28 equals 84. Then you find factors of 84, two numbers that multiply to positive 84, but they add to positive 25. So they multiply to 84, but add to 25. Great way to do this is with a factor table. I'm looking for factors of 84, so they have to multiply to 84, but they have to add to 25. And you'll notice looking down the list, 1 and 84 add to 85, 2 and 42 add to 44, 3 and 28 add to 31, 4 and 20, hey, there they are, 4 and 21. 4 and 21 are those numbers. Notice how 4 times 21 is 84, 4 plus 21 is 25. Now comes the part where you turn it into a grouping problem. What you do is you rewrite the middle term. 3x squared, and it does not matter which order you go in. You're going to take either put the 4 or the 21 next. It makes no difference. I'm going to put the 21 and then I'm going to put the 4. Now you might just think, well, wait a sec, didn't we change the question? We did not. Look, 21x plus 4x is 25x. It's exactly the same question still. Now we can actually factor it easily. The way you do that is by grouping. You pair up the first two and you pair up the second two. And remember greatest common factor? This isn't really a greatest common factor because the greatest common factor would have to be in all terms. But we're going to do a GCF of each pair. See how the first two have a 3 in common, 3 and 21, and they both have an x? And I'm just looking at that pair now. 3x times something is 3x squared, that's an x. 3x times something is 21x, that's a 7. Now you bring down that sign. You must bring down the sign. There's got to be something there. Plus, and look at the last two. 4 and 28 are divisible by 4. 4 is the GCF. And 4 times x is 4x. And 4 times 7 is 28. What you've just done is turn this 4 terms into 2 terms. And the 2 terms are separated by this addition. Terms are joined by multiplication, and they're separated by addition. And those 2 terms have something in common. Both of them have an x plus 7 in them. So we treat that like a single thing, like it was an a. If there was an a in both terms, I'd use a greatest common factor and pull it out. So I'm going to pull the x plus 7 out of both terms and put it out front. X plus 7, and when I pull it out of this first term, that includes the whole thing, I'm left with a 3x in the first one. When I pull it out of the second term, x plus 7 is gone in the second term. I'm left with a 4. And this is your answer. If you FOIL this, you'll see you get that. And it's kind of weird, but what we really did is this. X plus 7 times 3x was x plus 7 times 3x. And x plus 7 times 4 was 4 times x plus 7. You don't need to do this, but I'm going to point out you can check this in your head. How do I check it in my head? X times 3x is 3x squared. 7 times 4, that's 28. And in FOIL, F-O-I-L, the outer and the inner make the middle term. Right here we get 21x, and right here we get 4x. And when I add 21x and 4x, I get 25x. This is my answer. This will start going faster. This is standard form with a number in front. I can't say factors of 14 to add to 23 because the 3 in the front helps create that 23 in the middle. So the shortcut here to figure it out is to multiply 3 times 14, and you get 42. I need two numbers that multiply to 42 but add to negative 23. And just like before, remember when you factor and you did this kind of thing, and it was a z and a z, this number times this number still makes positive 14. It's either two negatives or two positives. It's going to be the two negatives. And in fact, these two are going to be negative. Think about why. These two numbers right here, they multiply to positive 42, but they multiply here to positive 42, but they add to negative 23. And that's how I know it's going to be two negatives. Factors of 42 that add to negative 23, I believe, are 2 and 21. 2 and 21. Negative 2 times negative 21 is positive 42, and negative 2 plus negative 21 is negative 23. So we use this information to rewrite the middle term. 3z squared. Now I can either put the 21 or the negative 2 next. I'm going to put the negative 2 for variety here. Negative 2z minus 21z plus 14. Notice how negative 2z minus 21z is negative 23z. Still the same question. We're looking for a GCF in the first pair. This is factoring by grouping. There are 4 terms. That's how I know it's a grouping question. All they have is a z. Z times 3z minus 2. Bring down the minus. Now be aware that when you pull out a negative like that, it's going to change both signs in this. The GCF is 7, and you're really multiplying negative 7 times something to make negative 21. Well, that'd be positive 3z. And negative 7 times something to make positive 14. Well, that'd be negative 2. Negative 7 times negative 2 is positive 14. I can see that both terms have 3z minus 2 in them. I'm going to pull that out front. And when I do that, this times the first spot makes that. You're left with a z. When you pull 3z minus 2 out of the first term, you're left with a z. And 3z minus 2 times the second spot makes the second thing. And that'll be a negative 7. In other words, when I pull 3z minus 2 out of the second term, I'm left with that negative 7. Check this in your head to make sure it's right. 3z times z is 3z squared. We're good there. Negative 2 times negative 7 is positive 14. We're good there. On the inside, negative 2 times z is negative 2z. On the outside, 3z times negative 7 is negative 21z. And when I add those two together, I get negative 23z. This is my answer. And we get one with the last sign negative. The process is exactly the same. I take 8 times negative 9, and that gives me negative 72. So I need two numbers that multiply to negative 72, but when I add them, they add to negative 6. And those two numbers are 12 and 6. 12 times 6 is 72, and I need to make negative 72. One of them's got to be negative, but I need them to add to negative 6. They must add to negative 6, which is negative 12 and positive 6. I'll rewrite the middle term, 8w squared minus 12w plus 6w minus 9. The first pair have a 4 in them and a w. 4w times w, that would be 2w, minus 3. And the last two have a 3 in them. 3 times 2w, always bring down that sign, minus 3. And I'll pull out the 2w minus 3 of both terms, and I'm left with 4w plus 3. And you can FOIL that to check it. The remainder of this video is questions from your assignment. The first questions are review, so we're picking up at question 6. This is the hard kind of standard form when there's a number in front, so I'm going to multiply 3 and 14. 3 times 14 is 42. And I need two numbers that multiply to 42 but add to 23. This is a lot like one in the teaching. The signs are just different. It's 2 and 21. And 2 times 21 is 42, and 2 plus 21 is 23. They're both positive. I'll rewrite the middle term. This time I'll put the 2 here. It doesn't matter which one goes first. You can either put the 2 or the 21. No difference. 2w plus 21w makes 23w plus 14. I'm going to do GCF out of the first two. It's a w times 3w plus 2. Bring down the plus. The last two have a 7 in them. 7 times 3w plus 2. Both terms have 3w plus 2 in them. I'll pull that out. 3w plus 2. Pull it out of the first term, you're left with w. Pull it out of the second term, you're left with 7. Question 7. We got the hard kind of standard form. We're going to multiply 5 times 6. 5 times 6 is 30. I need two numbers that multiply to 30 but add to 13. 3 and 10. 3 and 10. 3 times 10 is 30. 3 plus 10 is 13. Both are positive to make positive 13. This is 5y squared. You can go either order. Either put the 3 or the 10 next. It makes no difference. I'm going to do the 10 because I like it with the 5. Plus 3y plus 6. First two have a 5y in them, times y plus 2. Last two, bring down that plus, have a 3 in them, times y plus 2. Pull out the y plus 2 from both terms, and y plus 2 times 5y plus 3 is our answer. Question 9. We're going to multiply 4 times 21. 4 times 21 is 84. I need two numbers that multiply to 84 but add to negative 31. I went to my factor table. I'm trying to find two that add to 31. There they are, 3 and 28. 3 and 28. They have to multiply to positive 84, but add to negative 31, which means they're both negative. This is what we use, negative 3 and negative 28. Rewrite the middle term, 4y squared. You can go either one, minus 28 or minus 3. I'll do minus 3 for variety. Minus 3y minus 28y plus 21. The first two only have a y in them. Y times 4y minus 3. Bring down the minus. Last two have a 7 in them. 7 times 4y. Now, careful here. Negative 7 times 4 is negative 28. Negative 7 times something is positive 21. That's going to have to be a negative because a negative times a negative makes a positive. And that would be 3. Both terms have 4y minus 3 in them. Pull that out. And we get y minus 7 as our second factor. FOIL it and check it. And question 10 is another standard form. The last sign's negative. I'll take 5 times negative 28. That's negative 140. I need two numbers that multiply to negative 140 but add to negative 31. I think I'm going to use the factor table here. You heard me say factors that add to negative 31. Well, notice something here. Two numbers that multiply to negative 140, they have to multiply to negative 140 here. And if they multiply to a negative, one's got to be positive and the other's got to be negative. And when you add a positive and negative number, it's actually easier to think in your head anyway. Subtract. Take a look at the factor table. Notice that I don't worry about the negative. I'm looking for numbers here that subtract to 31, and there they are, 4 and 35. But as I said, really they add to negative 31. You've got to make 4 and 35 add to negative 31. Well, since it's negative 31, it's going to have to be negative 35. You have to have more negatives. And positive 4. These two add to negative 31 and multiply to negative 140. Let's rewrite the middle term. 5z squared, and you can go in either order. I'm going to put the minus 35 with the 5 because I like factoring out 5. Minus 35z plus 4z minus 28. And if you want to switch these two around the order, it makes no difference. Your answer just ends up being flipped. That's the only difference. Like instead of x plus 3 times x plus 2, it's x plus 2 times x plus 3. So still the same thing. First two have a 5z in them times z minus 7. The last two have a 4 in them times z minus 7. Pull out that z minus 7 from both terms and you're left with 5z plus 4. And we can check this in our head very quickly. Z times 5z is 5z squared. 7 times, that's negative 7 times 4 is negative 28. In the inside, we get negative 35z when we multiply. On the outside, we get positive 4z when we multiply. And these two together add to negative 31. We know we're correct. This is our answer.